I'll be explaining the two main properties of dynamic programming, which is optimal substructure and overlapping subproblems. So basically, optimal substructure is nothing but dividing a large complex problem into many simpler subproblems, and then we try to find the solutions to this individual subproblem separately, and finally merge them to get the final solution. Whereas if you see overlapping subproblems is generally there might be many repeated cases of subproblems where we are required to solve the subproblems again and again. So instead of computing the solutions for the subproblems again, we can just calculate it once and store it and use it later on. So this is basically overlapping subproblems. So I will be explaining it with a diagram so that it will be clear. So if we see the problem that we had taken earlier, this is the starting state which is represented as 0, comma 0. So there are multiple paths. So assuming one of the paths is this, so one of the paths is moving towards left, moving towards right, then again right, from that again right. So when he reaches 0 comma 3, which is basically exceeding the island, or basically crosses the island, so he it will return back false. So he will iterate one step backwards, and from 0 comma 2 he will move down. So from that he can move to 1 comma 2, and after reaching 1 comma 2 there are again two possible paths. He can move towards right or move towards down. If he moves towards right, he will reach the out of bound, so it will terminate at that case, and so there is only one last possible path left, which is moving down 2 comma 2. So if he follows the path, it is shown in the diagram. So this is the path that he follows. So in this path, basically the total kilometers that he travels is 1 plus 3 plus 1 plus 1 plus 1, which is 7. So at 0, so now we backtrack to the position 0 comma 1. So at 0 comma 1 he had two choices. He can move either right or towards down. Initially we took the condition where he moved towards right. So now let us consider that he moved down instead of moving towards right. So from 1 comma 1, again there are two possible cases, either moving towards 1 comma 2 or towards 2 comma 1. So assuming that he moves towards 1 comma 2, and from that we assume that again he moves towards right, which is 1 comma 3, and 1 comma 3 is basically one of the dead ends because he's basically reaching out of the island, so we'll return back from that case. So from 1 comma 2 he can basically move down. So if he moves down, he will reach 2 comma 2, which is the final destination. So this is the path that is specified. So in this he travels 1 plus 3 plus 5 plus 1, which is actually 11 kilometers. So similarly, if we see when he was at 1 comma 1, instead of moving towards right, he could have moved towards down, which is 2 comma 1. So when he moved towards down, he would have gone to 2 comma 1, and from 2 comma 1, he could have moved either right or towards down. Assuming that he moved towards right, he will reach 2 comma 2, which is the destination. But if you had moved down, it will be 3 comma 1, which is out of bound of the island, and that's why it will be one of the dead ends. So in this state, the total kilometers covered will be 1 plus 3 plus 5 plus 2 plus 1, which is 12, as represented in the diagram. Similarly, we'll be trying out all possible cases. So this is another case in which he will move towards down. He will move first down, then right, then again down. So this in this state he will travel up to 9 kilometers. Similarly, we'll try out all possible paths until he finds the goal, that is a path that is less than 8 kilometers. This is also one of the paths. So if we see uh, what overlapping subproblem generally means is, if we see this subproblem, for example, finding the solution for 1 comma 1. So if we see, we would have already calculated it when we were calculating for the left half. And so when we encounter this 1 comma 1 subproblem again in the right half, instead of repeating those calculations again, we could have used the solution that we had found earlier. So it would be saving a lot of time if we do that. This is what overlapping subproblems generally mean. So in overlapping subproblems, basically, the same sub problem is encountered again. So in that case, we are basically repeating all the calculations and computation to find the solution of the subproblem again, which is basically a waste of time, right? Since we had already found it earlier, we could have used that solution directly instead of going through the calculations and hectic it and all the hectic to find the answer again. So that is what overlapping subproblems mean. And coming to the time complexity for this approach is, so basically at every possible cell, the user can move either towards down or right. So there are two possible cases at every possible cell, right? So assuming there are n cells, so it will be 2 power n combinations, which is exponential. So this is actually a lot, and our computer will take, or our program will take a lot of time to run a problem which has a time complexity of 2 power n. So a dynamic programming approach is generally used for such problems in order to accomplish the time constraints.